In this video, we are going to discuss about Papaverine Pavine Rearrangement reaction, right? So this is a simple rearrangement reaction, right? So we know the structure of Papaverine. The structure is like this. See, let me draw it here. So it is isoquinoline ring it contains, and this is the basic nitrogen, right? And here we have CH2, and here we have again benzene ring, yes, and we have ortho position, para position OCH3, and at meta position we have OCH3, right? Sorry, let me try it. OCH3, right? And it is a aromatic ring, aromatic isoquinoline structure, OCH3 and again OCH3, right? So this is the structure of pavine, right? To this, sorry, papaverine, right? To this, if I add HCl, there will be equilibrium. So HCl means there will be H plus and Cl minus, right? So these nitrogen lone pairs, which I am showing it by lone pair, right? So it is basic in nature, so it can give its electron density to the H plus, that is electrophilic, that is proton H plus. It will easily give because nitrogen in this papaverine is basic, right? So it gave the lone pair. So what we will get? So we will get again this structure, right? So these things you should know, right? CH2 benzene ring, and here it is OCH3 OMe. I can write instead of writing OCH3, here also OMe, and here also OMe and OMe, right? So nitrogen gave its lone pair, so nitrogen will get positive charge as I have shown with the red, right? And other things, the pi bond, everything will remain as it is only, right? So this is the thing. So nitrogen is a electronegative atom, right? Electronegativity of nitrogen will be around 3.0. Since it is a electronegative atom, it can't have positive charge. So what it will do, it will take this pi bond. If you see this pi bond, it will take. So as soon as it takes the pi bond, the carbon will get positive charge. So what happens? It will become like this, right? Just you write along with me so that it will be clear to you. So nitrogen got the lone pair back from this carbon. So this carbon gets positive charge now. So this carbon gets positive charge. This carbon gets positive charge, and other things remains as it is only. Right, other things will remain as it is only. OMe, OMe, and here also OMe and OMe. Right. So like this we got, right? To this, what they will do, they will add this thing, tin, and HCl is there in the solution. So excess of HCl they have added. So tin in HCl they will add, right? Just tin metal. So tin is a metal, right? So it has the ability to convert into Sn2 plus 2 electron. Means a metal is a substance which can easily give the electrons, right? Because here it will give 2 electrons. It can easily give electrons, right? So what happens? See. So Sn will give 1 electron. 1 electron, if it is taken by this positive charge, it will become neutral. Again it will give 1 more electron. Totally it will give 2 electron. Then this positive charge becomes negative charge, right? Are you getting? First, when, see, this is the positive charge. When it gets 1 electron, what happens? It becomes neutral, like this, neutral. Further, when one more electron takes this neutral compound, it becomes negative charge, right? So initially this proton, which was positive, now becomes negative after getting 2 electron from this tin, right? So let me draw the structure again. So what happens? The thing is OCH3 nitrogen, right? This carbon was positive, right? This carbon became negative now, right? Further, since HCl is excess, so H plus will be in excess, so this negative charge will take this proton and becomes neutral, right? So let me draw it like that only, right? So how, what happens totally? So it got this negative charge and became, and this proton reacted and it became like this, right? And other things remains as it is only. So here benzene ring, OMe, OMe, and other things will remain as it is only, right? So this is the structure we are left with, right? This is the structure. Further, what happens? See here. So further, what happens is that so H plus are there in excess because HCl excess HCl the we are making the reaction. So here nitrogen is having lone pairs, right? So see, this electron density moves here, nitrogen gets positive, this pi bond will move on this carbon, through this carbon it will attack this proton H plus. So what we will get? So we will get this reaction, right? So what happened? So this nitrogen pi bond shifted here from lone pair, and here this H plus attacked, sorry, and it became neutral. So let me write H, simple H. And this nitrogen, since it gave its lone pair, so it gets positive charge. And other things, this hydrogen remains as it is, this thing remains as it is. OCS3, OCS3, and all other things, right, will remain as it is only. Pi bond, right? But nitrogen is electronegative atom, so it can't have positive charge. So again, what it will do, it will take this pi bond and it becomes neutral, right? So with the red marker, I have shown it. So what happens? So here OCS3, OCS3, everything will remain as it is. So again, benzene ring here, OCS3, OCS3, and here it is. Nitrogen again became neutral, right? So OCS3, OCS3, and here this carbon is having positive charge now because it took the pi bond. So nitrogen is having one H, so it became neutral. Further, what happens? See, this is very interesting. So here what happens is that this electron density is there, right? So if I count like this, 1, 2, 3, 4, 5, 6, 6-membered ring formation happens. How it happens? See, this oxygen is having lone pairs. So this lone pair will be like this conjugated. So this by sorry. Yes, just to see what I wanted to show. So these lone pairs are there, right? So these lone pairs, as soon as it comes here, this pi bond comes here, and through this one, it will attack to this 6-membered ring, right? So instead of making it the same structure, if I rotate it like this, so we'll get it, right? So see, 6-membered ring formation happens with the red marker which I have written, right? So the same 6-membered ring formation happens. OCS3, OCS3. Here benzene ring is there as it is, and here nitrogen NH, and here CH2. Let me write it here again. Here let me write. So see now. So this was my 1. Again I'm writing the same structure. 2, 3, 4, 5 is nitrogen, and 6 is this carbon, which is electropositive now. So electrophilic substitution kind of reaction in which carbon-carbon bond formation happens, right? So the same structure I am writing here, right? The same structure. So at one next there is nothing here. OCS3 we have, this OCS3 I have, same OCS3 here, and this OCS3 is there, right? That thing I will write here, OCS3, right? And here we have like pi bonds. So what happens? Here electron density it will give, so carbon carbon bond formation happens because both are carbon. This is also carbon, this is also carbon, carbon carbon bond formation. It is a kind of electrophilic substitution, right? So here rearrangement it is happening within the molecule, within the molecular reaction is happening means rearrangement. So here carbon carbon bond formation is happening. So as soon as it gave, this pi bond gave the electron density to this carbon, this carbon gets positive charge. Further, this pi bond shift here, this pi bond will shift here, it will give its lone pair like this, it will be stabilized, right? This is how it can be stabilized, right? So directly can I write it like this? So here you will get it. So it will be like, see, uh, so it is the ring OCS3, OCS3, like this. So pause like this, right? So here ring formation has happened, 6-membered ring like this. right? Right. So double bond here, double bond here, double bond O, Me. Now oxygen, as it gave the lone pair, so it will get positive charge, right? And here this carbon carbon bond formation, let me show it by blue color. This carbon carbon bond formation was the new bond formed within the molecule, right? So this is the reaction, right? Other things are same as it is. Nitrogen is having one proton, NH. I can show it here like this, right? So here one proton is there. So this compound, if you see, it is anti-aromatic. So re-aromatization is the driving force for this further reaction, re-aromatization. So how it happens? This proton will be removed like this, pi bond will shift here, and this proton will, this pi electron will be taken by oxygen, and it gets its lone pair back. So how it happens? So we will get this compound like this, right? So let me not draw here, I'll directly draw here. So this is the re-aromatization step, so that I required more number of space here. So here nitrogen, right? OCS3, OCS3, and here ring formation is happened, right? And other thing will remain as it is. So it is again aromatic now. OCS3, OCS3, right? This is also CS3, right? This is the thing has happened, right? And it is again aromatic here also, right? So this is the ring, right? And it is NH bond, not N, simple NH. So you can see here, if you see the stereochemistry of this NH, see it is between 6-membered ring. Here also see, it will be like, see, if I want to draw it, I can draw it like this. Two sides 6-membered ring are there. 1, 2, 3, 4, 5. 5-membered ring it became, right? 6-membered ring I should show, so that it will be clear, right? So this is the this structure we call it as pavine, right? So this is nothing but our Papaverine Pavine rearrangement, right? Further there is aromatization, and we got this thing, right? So if I want to show how this nitrogen exists, if you can check, see here, if I number it, you will get it here only. So see, so if I number nitrogen 1 to this carbon, 3 to this carbon, this is 4, 5, 6. So here 6-membered ring is there. Again here 1, 2, 3, 4, 5, 6. There are two 6-membered ring with nitrogen as a common, right? So if I want to draw it nicely, I can give it like this. See, so this is NH, right? So 6-membered ring, I should show it, right? Other things will remain as it is only, right? Yeah, count whether it is 6-membered ring. So it is, see, just count it, 1, 2, 3, 4, 5, 6, yes, right? One more ring I will show with red. Nitrogen is common to it, and to see like this, 1, right? Sorry, I should have done with red marker only, right? This is also 6-membered ring, right? If I count it with any other marker, which one should I take? Let me take white one. So 1 is nitrogen, 2 is this, 3, 4, 5, and again this one is 6. So 2 6-membered ring, and next to that ring we have the structures. So here we have again like this structure, which is benzene ring, and here OCS3, OCS3, and here to this structure we have again benzene ring, it is OCS3 and OCS3, right? So this is the nothing but our pavine, in which nitrogen will be above the plane, right? All these are within the plane. This is planar, no doubt. This is also planar, right? So it will be having structure like this, in which nitrogen NH will be above the plane like that, right? So this is the stereochemistry you can think. So this is pavine. So from from papaverine we got this pavine. Both structures are same only, right? So this rearrangement we call it as papaverine to pavine rearrangement reaction. I hope you enjoyed the video, right?